Now we will be starting with the types of heat exchanger. We will start with parallel flow heat exchanger and counter flow heat exchanger. Parallel flow and counter flow. Let me show you with the help of a diagram. This is a pipe, concentric pipe. Let me show you its cross section. This is the cross section view of the pipe. Let the pipe contains two fluids. The direction of both the fluids is in same. The flow is in same direction. You can see here. This is parallel flow, and in counter flow, the flow is opposite. You can clearly see here the flow in both the pipes is in same direction. Here the flow in both the pipes is in opposite direction. Let me show you this area. This area I am enlarging it here. In case of parallel flow, both are moving in same direction. Let this is T H inlet, T H exit, T cold inlet, T cold exit. Now let us make the temperature profiles in this case. THI, temperature of a hot fluid, and we are saying it is at inlet case. The temperature profiles will be parabolic. In case of parallel flow, we will see the temperature profiles as this. Parabolic, this would be THI, this would be THE, this would be TCI, TCE. X direction, we are moving towards the flow. We can see the temperature profiles. Let's see what can be the limiting case. The limiting case, we are saying when the TCE can be maximum. We can clearly see TCE can be maximum, which can be equal to THE, that is T hot exit. We forgot to make the arrows. These arrows are very important. Whenever you make a diagram, make sure you are making this arrow. This arrow will tell the fluid is moving in which direction, so it's parallel flow or counter flow. Let's see the limiting case. This is the limiting case. TCE can maximum be equal to THE. It cannot be exceed THE. Let's see the case of counter flow. In one, we are saying it is moving in this direction, in other it is in opposite direction. Let us say this is TC, THI, THE, TCI and TCE. Let us make the temperature profiles. We see THI, THE. These are the opposite direction. The temperature profiles here also will be parabolic. This is THI, THE, TCI, TCE. Always remember to make these arrowheads. We can clearly see that in case of counter flow, TCE can be greater than THE because the limiting case is this. This is a limiting case. So in case of counter flow heat exchanger, TCE can be greater than THE. These are subscript. H means hot, I means inlet, and E means exit. So in this case we can clearly see TCE can exceed THE. Let us take an example. IES 2014 question. Let me solve it here. IES Indian Engineering Service 2014 question. Let me read the statement of the question. In a two fluid heat exchanger, the inlet and outlet temperature of hot fluids are 65 and 40 degree Celsius respectively. That is T hot inlet is 65 degrees Celsius. T hot exit is 40 degrees Celsius. For the cold fluid, for the cold they are giving the conditions. For the cold, TCI is equal to 15 degrees Celsius and the exit temperature of cold they have told is 43 degree Celsius. They have given us these four conditions and the question is the heat exchanger is a parallel flow heat exchanger. Parallel flow is first option, counter flow is second option, mixed flow is third option, and the phase change heat exchanger it is the fourth option. So let's see. It is a parallel flow, counter flow, mixed flow or phase change heat exchanger. Initially I will ask you to that we will concentrate on parallel flow and counter flow. Mixed flow and phase change we will be studying in ahead topics. So we will see if it can be parallel flow or counter flow. We can clearly see that TCE can never exceed THE in case of parallel flow heat exchangers. But in case of counter flow heat exchanger, TCE can exceed THE. Here TCE is greater than THE. So we can clearly make out it is not a case of parallel flow heat exchanger, it is a case of counter flow heat exchangers. And in case of mixed flow the temperature cannot exceed, and in phase change, let me make a point. In case of phase change we will be studying it in ahead topics also, but let me tell you, in case of phase change, the diagram is like this. In a phase change, when the phase is changing, the temperature of one fluid doesn't change. So it is something like this. in case of parallel flow. So one temperature doesn't change, but here in this case we can clearly see the temperature, no temperature is constant. So it is not the case of phase change, we can depict. So answer of this question is quantum flow heat exchange.